Okay, good evening, everybody. Those who want to switch on their cameras and or microphones, they can.
There was one question in that Google form, so that is in the chat box. So they were asking about the same thing, like which are the books that they can follow.
Can you, okay, let me open the Google.
Yeah, it's in the chat box.
Which chat box?
Zoom chat box.
I joined it later, so therefore,
Oh,
okay,
okay.
fine.
Yeah, so he sent it.
Yeah, I got the link. Yes. Okay, Shad Azmi. Uh, Not. Yeah, I mean, I don't really follow any particular book, but I tried to answer this question on a Google uh, chat. Yeah, so there is a discussion forum for this course. So over there, I tried to answer this question. Maybe what I can do right now is perhaps I can open the same chat box and I can read out the things that I said there because I don't want to be inconsistent. Yes. So yes, that there was a question by Himanshu. So there are, because the material is not taken from any one particular source, so there will be various different books for different parts. And as you have seen so far, the material changes almost every week. Okay, so for basic set theory, so set theory can be taught in two different ways. Either it can be naive set theory or it can be axiomatic set theory. So, but for this particular course, I'm following neither approach. It's not entirely naive set theory. So, for example, the set of students in the classroom, yeah, or the set of people on the earth, that is not a set with respect to Zermelo-Fraenkel set theory. But the set of the collection of sets is built from the empty set step by step. So there is some axiomatic flavor, so abstract flavor, and there is some naive flavor that we do not try to be too rigorous to construct every single operation on sets using the axioms. So therefore, like you have, if you want to read some material, then you have to read a mix of naive as well as axiomatic set theory. And my and for any particular part, yeah, for example, if you are looking at continued fractions, then they are taken from number theory. Then Cantor's set, etc. These come in analysis. If you do a first course in analysis, then usually these things are covered. Even in major theory, then there was some part on lattices this week, recent week. Yeah, so so yes, so lattices, for that you can use Gretzel's book. Then for Boolean algebras also you can refer to. I mean, generally what I would suggest is you Google the keywords which are important, and that's the modern way of learning things. Yeah, so Yes, Vishal, you have asked
I
assignment questions are different from your lectures. I
I think
mean,
first you should answer the next question. So
okay, fine.
if not books, then there are problem sets that you would recommend.
If not book, then there are any problem sets that you recommend. Okay, so I mean, this is as you have seen through the video lectures that this was a live course that I taught last semester. So on my own website, my own personal website, if you click on MTH 302, that is set theory and logic course, that's under courses tab. So you will find assignments. I used to give my students assignments every week, and there will be more descriptive problems. I can't give you entire assignments here because this NPTEL course is meant to be uh, more multiple choice question based. So that's why I'm not providing you entire assignments, but you are of course free to try them. Yeah, there are 12 assignments for 12 weeks. So therefore you can try solving multiple problems. Yes. And yes, Vishal, so your question is that assignment questions are different from your lectures. I mean, if you are expecting that it will be directly taken verbatim from the lectures, then that's not going to happen. For example, if you are studying Cantor's set, then you have to play around with Cantor's set. You have to play around with ternary expansions, right? So then there will be some questions based around applications of that. And please believe me, I have asked similar difficulty level questions in my actual course also. Yeah, the live course that I had. In fact, the questions would be a bit harder over there because people have more space to write. The entire point of this course is that you should be able to uh, write more confidently about mathematics. And if you become more rigorous, then you become more confident. That's the entire goal. Yeah, so if you practice more, and definitely Vishal, Arun Kumar, yeah, I mean, whatever questions you have, please send them to me. And our team is always answering the questions. Yeah, there is not a single question that we haven't answered so far. It's just that we don't have enough work on that front. Yeah, so do send more questions. Vishal, if you want to maybe clarify a bit more, then you can point out the questions and I can point you in the right directions. And is there anybody else here? Like, who is this person D? Okay. Okay. You don't know who is D. Unless there are questions, what will I do? I don't know. Mr. or Miss D? Yes. Yes, yes, definitely. We'll wait for some time. Yes, yes. Please check YouTube chat for questions. Maybe I will also log in to your YouTube link. I'll try to mute that as soon as possible so that there is no disturbance. Okay. Yes. Munir, good evening. Yes. Any questions? No, okay. Okay, Vishal, uh, your query was answered. Okay, whoever was D, they left. Okay, if you don't have any questions, then perhaps I can ask questions. Are you finding the course easy, hard? Even if you are listening to me on live YouTube session, try to answer that. Any particular topics that you found hard? Okay, so we are up, like day after tomorrow, we will upload lecture 6 lectures,
Uh, we
week 6 lectures, and this week will entirely be about Boolean algebras, and then we are done with half of the course. Yeah, set theory and order theory part is done completely, and next week onwards we'll start with propositional logic. So logic part will begin. There will be again an introductory mm, lecture on what is logic, similar to the first lecture ever. And I mean, the main purpose of this course is you should branch out in different directions. I'm giving you some pointers, yeah, maybe partial orders. Yes. Uh, Arun Kumar, yes, the content is, the pace is tough to keep. I mean, yes, I do understand that this is an extra course that you are doing apart from what you are, whatever your regular commitments are. Yeah, so that way I do appreciate those who are taking this course seriously. And yeah, I mean, usually like there are 3 lectures per week, and you can watch them at your own speed. So if you are willing to take up the burden, if you are doing many other courses, then I don't know what advice I can give you. But if you are just doing this course extra from your regular commitments, then I feel like you can keep up. Yeah, and I want people to solve assignments properly. Like, see, exam is not really the purpose here. Exam and getting scores is not the purpose, but rather it should be that you understand and appreciate the kind of things that are not normally covered in in any undergraduate level course, at least in India. Yeah, if you talk about set theory, then set theory is a, if you look at, let's say, the high school or junior college syllabus up to 12th, then set theory is usually an optional subject for people preparing for JE. Yeah, then logic, well, Indians look down upon logic, like the Indian mathematical community in general. So therefore, that was another purpose, that the Indian community should be well versed with this important subject. It's the foundation of mathematics. So we should give it due respect. Like in the past, I have tried to teach logic at some, I mean, not just me, but other people also have tried to teach logic at logic schools. But they happen only for a class, not masses. Whereas through NPTEL, I'm trying to reach out to masses that they can appreciate this beautiful subject. There are some very important results in this area which decide, like especially Gödel's incompleteness theorem that you will see at the end. That's the boundary of what a human being can do with these kinds of axiomatic systems. Now there are, these are very beautiful things, beautiful results, and at the same time, I also want everybody to look at some niche techniques or some niche topics, yeah, which are not normally covered. So, for example, order theory is also not properly covered in any course. Yeah, you generally just know the definition of a linear order. That too is not properly taught. Linear order, partial order. So that way, I think this course will provide some background, common background for people to talk about it. What would help is give 2 weeks to solve the assignments. And there are 2 weeks to solve the assignments, if
Yes,
you have
yes.
noticed. Yeah, there are 2 weeks. Perhaps you are looking at them a week later. For example, tomorrow we are supposed to release solutions to assignment 4. Yeah, because today is the last date for assignment 4. But at the same time, day after tomorrow, we are releasing content for week 6. So 4 and 6, that's a 2-week gap.
Yeah.
Okay, so maybe I can check something from this chat. Ramraj, good evening. What is good book to follow with your course? I tried the Joy of Sets of Devlin, but no, I don't follow any book. Yeah, the sequence of topics will never match with my lectures. I usually uh, plan the course in advance, and it's it's a lot of content, that I agree. And then whatever I need to cover that day, I look at lots of resources together. I Google these terms, and then I cover the material. And as I mentioned at the beginning of this session, that it's neither naive set theory nor axiomatic set theory. It's somewhere in the middle. I want to give you all the flavor of axiomatic set theory, but not be too rigorous. Because, for example, I have studied a full course on axiomatic set theory, and it can become very, the rigor can make it boring to some extent. Uh, unless you are too much into abstraction, otherwise most of you would have run away already. So that's not the purpose. You should appreciate set theory for what foundations it brings for entire mathematics. Yeah, I do not follow any particular book, so you just have to keep up with the pace of the course. And if you want any particular references for a particular lecture or a particular topic, then you should definitely let me know. I will find lots of references. I mean, my way of finding is also going to be just Googling and finding out 3-4 hits, whatever is appropriate, and then I will send the material to you. So do write to us. Any more questions? There are 6 people watching right now. You should say something. You can ask any particular doubts. Yeah, any mathematically rigorous doubts as well. I already tried to send an email at the beginning, like in the around second week, that you should discuss this more, because most of the learning happens when you talk about these things. It doesn't happen when you are on your own. Maybe at the end of the day, yeah, whether you are a student or doing a job, you are curling in your bed and then you are watching these lectures. Well, then it's not going to help. Yeah, you have to actually spend time with this course. Yes, Murli, I understand there are people watching. Out of those 6 to 7, perhaps 3 of us are 3 members, and like maybe three people more. Yes, I'm studying set theory and logic to understand contemporary philosophy more properly. Oh, okay. Well, on the on philosophy side, I'm a complete idiot. Okay, I have no idea, but in mathematical philosophy, I can definitely appreciate, and I have tried to convey it as much as possible in my lectures. So, Ramraj, you are from philosophy background. Yeah, I mean, if you are looking for contemporary philosophy, then perhaps this course is not for you, because most of the material covered in this course was discovered, let's say, uh, between 70 to 100 years, 70 to 150 years ago. Yeah, so it all begins with Cantor from 18, like late 19th century, 1880s, 1890s. Then after that, Hilbert proposed, because Hilbert really wanted to support Cantor's idea of formalizing mathematics. Right. Just for fun, I should also add that in the past there was no notation for writing mathematics. People used to write words in their respective languages for mentioning something. So notations became part of rigorous mathematics. Then came in formalization, like axiomatization, yeah, because the notion of set also took many years to develop. People knew about the set of integers, set of real numbers well before the human beings had discovered the notion of a set. And whatever naive approach came up, then that had many flaws, as you know from Russell's paradox. So then eventually, Hilbert, who was one of the most profound figures in mathematics at that time, he decided to support this axiomatic system. And in one of his problems, if you know, there are Hilbert's 23 problems. So one of his problems was about whether we can axiomatize entire mathematics. And that particular question has given us lots of uh, Mathematics. Okay. So Anjali, so how to check if the ordinal arithmetic that one has done based on how they were defined is right? Is there some practice book with solutions or something? So Anjali, I should point out that uh, my other TA, Nupur, yeah, she has recorded some piece in that tutorial session for last week. So if you look at, like, it's a very detailed solution of omega plus 1 to the power omega is equal to omega to the omega. Whatever ordinal arithmetic that you need, that will be contained, I mean, within that. Yeah, so all the techniques of the proof are already there. Yeah, how you use your transfinite recursion, and how addition is defined, how multiplication is defined. Yeah, so you will get all those hints from that particular solution. And there are like any axiomatic set theory book, any advanced book, for example, Kunen, yeah, you will find lots of exercises on ordinals. Yeah, the ordinal arithmetic is very interesting because it's a very natural but non-commutative arithmetic. Usually when you think about addition, then addition is obviously, like, when you think about addition, even if it's clock, everything is commutative. But ordinal addition is not commutative. But still, ordinal multiplication distributes over ordinal addition only from one side. Yeah, not from both sides. And I'm trying not to say this because perhaps that will give away some solutions to the assignment problems. Yeah. Yes. Yes, and but whether you can find something solved or not, that I'm not sure about. Yeah, ordinal arithmetic, you just have to work with your hands. You have like, we start feeling why ordinals are infinitely many and a proper class many. Like, if you start playing this game, the powers of omega, then epsilons, epsilon naught, epsilon 1, blah, blah, blah. All of them are themselves countable ordinals. And then eventually we can guarantee existence of omega sub 1, which is the first uncountable ordinal. And then the journey continues. Yeah, omega sub 1, omega sub 2, and so on, so forth. Yeah, that's a very beautiful journey. And unless you like struggle with that idea, yeah, uh, it's not possible to get these computations right. One hint I can give you, Anjali, is that ordinal addition. Yeah, so suppose alpha is the first ordinal. Yeah, so this is the zero part. I'm trying to do it from your perspective. This is zero, and then this is the like, this is increasing direction. And if you want to understand alpha plus beta, where this is beta, then the order type, the order isomorphism class of alpha plus beta is precisely this. Yeah, so you take a copy of alpha and then take a copy of beta, and that is what will follow from the definitions as well. So it's like putting two linear orders one after another. And well-ordered sets have this interesting property that if you put one well-ordered set followed by another, then that is again a well-order. Yeah, so therefore ordinal addition has this particular property. Then ordinal multiplication is also has some interesting description in terms of order theory. And similarly, ordinal exponentiation, but that one is a bit hard. Yes. So if you play around more with linear orders and well orders, then you will understand, or you will appreciate ordinal arithmetic even more. Yeah, that's as far as I can go right now. Shad, you have asked possible connections of this course with the idea of Turing machines and computations. Well, you still have to wait for the next part of the course. Yeah, so you have to wait until the end actually. Yeah, in the last lecture I talk a little bit. Last lecture on Gödel's incompleteness, I talked a little bit about recursion theory. So Gödel came up with recursion theory, like recursive functions. Then Turing came up with this computability notion, and then Church had lambda calculus. And it turned out that all these three genius minds, whatever they were thinking, that was equivalent. There is a perfect dictionary between these three. Yeah, lambda calculus of Alonzo Church, Gödel's recursion theory, which he used in Gödel's incompleteness theorems as we know them right now, as well as this. What was the last one? Turing computability. Yeah, so that will happen in the future. And I mean, computability is a different course altogether. So but Gödel's incompleteness and logic have had a major role in the development of this subject, yeah, computability theory, especially Hilbert's second problem. Okay, so Arun Kumar, I'm yet to watch cardinal arithmetic lectures, so please ignore if this question is answered. Will you be covering continuum hypothesis? If not, could you possibly cover it in one of the future lectures? Okay, so what do you mean by covering continuum hypothesis? Continuum hypothesis is simply the statement that 2 to the aleph naught is equal to aleph 1. So if you study like some more advanced set theory, then you can show that, I mean, yes, to come back to your first question, Arun Kumar, I have spoken about continuum hypothesis in one of the lectures, but very briefly. Yeah, and it's just the statement which says that the first uncountable cardinal number, yeah, which is same as omega sub 1, that is like if you forget about the order structure in omega sub 1, which is the first uncountable ordinal number, that is same as 2 to the power aleph naught. So because you are talking about continuum hypothesis, it's not a conjecture at all. Yeah, it has been shown by in 1960s. Just a moment. Anay, do you remember who won the Fields Medal for forcing?
Paul Cohen.
Paul Cohen, exactly. So Paul Cohen has shown that continuum hypothesis is independent of the rest of the axioms of Zermelo-Fraenkel set theory. Okay, what is the meaning of independence? Like that will be talked about in the second half of the course, but just to give you a flavor of this idea, that if one of the models of set theory, there will exist a model of set theory, Zermelo-Fraenkel axioms, in which continuum hypothesis is true. Yeah, and there will exist a model in which it is not true, and both those models exist, which means it is independent from the rest of the axioms. Now, like how to explain continuum hypothesis in simple words, that if you take a subset of real numbers, then is that subset countable, or is it in bijection? Like if it is not countable, then is it in bijection with real numbers themselves or not? That's the like continuum hypothesis says that if it is not countable, then it is in bijection with one of the then it is in bijection with real numbers themselves. So there is nothing in between. Yeah, no cardinality in between the cardinality of real numbers, which is 2 to the aleph naught. Hopefully you have seen that so far, that real numbers are in bijection with power set of natural numbers and aleph naught. So there is nothing in between. which means that after Aleph naught, it's directly 2 to the Aleph naught, which is Aleph 1. Yeah, it's successor cardinal. Perhaps, I mean, I don't remember uh, how much of this I have said. Perhaps I'm repeating myself by doing so. Yes, any other questions? Maybe only a couple of people remaining on YouTube, or somebody new started watching YouTube live just now. If you have any questions, please ask them. And yeah, those who are there, yeah, it would be great if you could join the Zoom meeting next time. Instead of asking questions through YouTube live, you can actually talk. Talking is much faster because then I will understand how much you understand, and then we can talk in context. If you have any questions, then please post them within next 1 minute. Otherwise, we'll end the session. uh, Only we can wait for 1 more minute and then we'll end if there are no questions. I just want to remind everybody that you are allowed to submit solutions of your assignments multiple times. So please try to get them right. We would like to see you score well. And regarding one of the previous questions, that if in other courses you have observed that you can find all the answers to assignment problems in the lectures, then that's certainly not going to be the case with this course. Unfortunately, I'll make you work hard. Yes, Murli, I think we can end the session now. Okay, thanks everybody for joining, and I hope that in the next session next live session, there will be more participants with more questions and more ferocious discussion. Okay, thank you. Thank you, Murli, for being here.